Static analysis tools find security vulnerabilities in code by matching program paths that contain source-to-sink data flow without proper sanitization. However, studies show that users are demotivated to use these tools because they report too many false warnings due to the incomplete or wrong choices of security-relevant methods. This IntelliJ Static Analysis Tool plugin finds and reports taint-style vulnerabilities. It also provides the source and the sink methods, which help us to better understand the problem. The SQL injection findings are false positives since we correctly use the sanitizer method encode for SQL in line 20. However, the tool is not aware that this method is a sanitizer, so it reported the false positives. Lists of security relevant methods are often manually created after analyzing a program's code base. This time-consuming process may be incomplete or wrong, and therefore a more general and adaptable solution is needed. Our tool, SWAN Assist, an IntelliJ plugin, enables users to actively adapt the lists of security-relevant methods directly in the IDE. SWAN Assist uses SWAN, a machine learning approach for the detection of security-relevant methods in Java. The training set, which are the list of example methods, the features, which are properties of the methods, and the test set, which would be the code base, are the inputs for the vector classifier, which then outputs a list of security relevant methods. SWAN can be used in combination with other static analysis tools, like the one from our example. It helps the users to create a list of relevant methods required as an input for static analyses, for example taint or type state analysis. SWAN detects 4 types of methods: sources, sanitizers, sinks, and authentication methods. These methods are also further classified as common weakness enumeration or CWEs. The plugin allows users to interact with SWAN's learning process by giving feedback, which helps to improve the classification of the methods. SWAN Assist helps software developers to adapt method of interest to their code bases, which ultimately helps to improve the results from their static analysis tools. Security teams can also use the tool to automate the scanning of project code bases in the build process. Now I'll demonstrate the tool's workflow using our running example. We can access the features of the plugin from the action bar in the tool window, or we can also access them from the editor menu. After selecting the configuration file, the method list will be populated. These methods are either found in the project or its libraries. The icons indicate the method's classification. Sources are green, sanitizers are orange, sinks are red, and authentication methods are blue. We can also expand the methods to view the CWEs that are assigned. We want to make the tool aware of the sanitizer method encode for SQL, which the doGet method calls. We can right-click anywhere within the method definition, select SWAN Assist, and then add or update method. Let's now change the type to sanitizer and set CW89 as a CWE for this method by double-clicking on the items in this available categories list. After adding the method, we can rerun SWAN to improve the classification. A notification will appear in the event log when the background process starts. The learning may take a few seconds up to several minutes, and we can then view the logs and also load the newly generated configuration file. In the results from our learning, we see that the tool also learned the sanitizer encode for Open Redirect. This demonstrates the active learning process that users can use to adapt the list to their needs and code bases. This new list can be exported and used by the software developers and security experts as needed.